Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwa Sos Ugobela Maths. And without any further ado, let's look at these questions that we have here. Okay, so we have question 7 on electrostatics. It says 2 point charges A and B are placed 3 meters apart, as we have been shown here. The charge on A is positive 6 times 10 to the exponent of negative 6 coulombs, and the charge on B is negative 3 times 10 to the exponent of negative 6 coulombs. P is a point 1 meter to the right of charge B. So point P here is what we call a positive point charge. Then 7.1 says define the term electric field at a point, right? So for 7.1, easy peasy 2 marks there. We say electric field at a point. So electric field at a point is the electrostatic force. The electrostatic force experienced per unit positive charge. Per unit positive charge placed at that point. Right. So for 2 marks, that's how you are supposed to define electric field at a point. Then 7.2 for 5 marks is saying calculate the net electric field at point P. Right. So always remember with this one, I said each and every charge here will be calculated in reference to the given point charge. So this will be charge A in reference to the point charge P, and then charge B in reference to point charge P. Right. So that's how you always calculate the electric field. It is not a charge relative to another charge, but it is a charge relative to the point charge. So now the first thing that you want to do is indicate a free body diagram of the electric field that will be experienced by point P due to the 2 individual charges. So we always note that P here has to always be a positive point charge. So if we have positive P and then charge A is also positive, we do understand that P will be repelled, right? So let's indicate, we say P will be repelled and then therefore it will go to the right. So we will indicate that this is EA. So this means this is the electric field due to point charge A. Due to charge A on point charge P, right? Then we have the point charge relative to B here. Because the point charge is positive and B is negative, we do understand that the point charge will be attracted towards charge B, right? So this will be EB, right? Now the reason I'm making this one much longer than that one, it's because here the distance is shorter. So with a shorter distance, the electric field experienced is much greater, right? So okay, now I've indicated, I will then indicate that I will take my right as positive as we normally do. So take right as positive, so these ones will be to the right and that one will be to the left. So okay, to then calculate, let me start with EA and then calculate the electric field at point charge P due to charge A. This is K, QA over R squared. Now be careful here, the K is a constant, 9 times 10 to the exponent of 9. QA, we have 6 times 10 to the exponent of negative 6. But then the distance here, it's not 3 meters, it is actually 3 plus 1 because this is in reference to the point charge. So the distance in between point A and point charge P is supposed to be 4. Right, and then square that. Now if you punch all that into your calculator, you get 3,375 Newton per coulomb. So SI unit, it's not newtons, it's not a force. This is what? Electric field. So this is coming from E is equals to F over Q. So your electrostatic force is newtons and then your charge is in coulombs. So obviously the SI unit for E will be Newton per coulomb. Right, so that's where we get that. And then we must indicate the direction, it's to the right. Now done with EA, let's now calculate EB. So for EB, again, it's K, and then QB this time over R squared. The K, 9 times 10 to the exponent of 9, and then QB, remember in this formula, you do not substitute the negative here. You simply just substitute the magnitude of the charge, right? And then there we go, over the distance in between point B to point P is only 1 meter. So it's 1 square. So this is in the desired SI unit. It's in meters, but if it was in centimeters or millimeters, you know that we needed to convert. So 27,000 Newton per Coulomb. And then this is going to the left. As we can see, our EB is going to the left there. Right. But then we are not done, obviously. We need to calculate the E net. So how do we then calculate E net? So this is the point whereby we say E net must be the sum of the two values. So it's EA plus, but then remember we said EB is going to the left, so we must indicate it as negative EB. So this is going to be equals to 3,375, and then plus times negative is negative, so it's minus 27,000, right? And then when you punch that into your calculator, you get negative 23,625, which we need to then conclude that therefore our E net is actually equals to 23,625 Newton per Coulomb. To which direction? Left. Right, to the left, because we took what? Right as positive. We took right as positive. So that means if we find our value as a negative, it simply indicates that it is going to the left. And that's how you were supposed to calculate that. And now we're going to proceed to 7.3. Okay, and then now we have 7.3. It says a proton is placed at point P. Calculate the magnitude of the initial acceleration of the proton if the mass of a proton is 1.67 times 10 to the exponent of 27 kg. Right. So with this question here, we can see that this is leading us to the Newton's second law formula, which will be F net is equals to ma. And this is the only way we can find the acceleration if we are given the mass. But then the first thing, obviously, that we will need to figure out is what is our F net, right? So from this, remember from the previous question, we just calculated the net electric field at point P, meaning that in order to get our F net, we can simply just use the formula that I just recently showed you, which is E is equals to F over Q, right? Whereby we can say that our E net will be equals to the F net over Q, right? So we just make edits to it and then put E net and F net, right? So, but basically the formula that we are applying is this one, so that we can end up having our F net. Now the E net that we just calculated from the above question was equals to 23,625, right? So we're just going to take it as a positive because now we are looking at the proton, right? So F net, and then even our Q here will be a positive. The charge on electron now will be the charge on the proton, which is now positive 1.6 times 10 to the exponent of negative 19. Now, if we cross multiply this, our F net is supposed to be 3.78 times 10 to the exponent of negative 15, and then newtons, right? So this is the force. Now, from this, we can then apply the Newton's second law formula. F net is equals to ma, whereby our F net is 3.78 times 10 to the exponent of negative 15. Our mass we've been given to be 1.67 times 10 to the exponent of negative 27, and then multiply that by the acceleration, which if we do multiply here, if we do divide both sides by 1.67 times 10 to the exponent of negative 27, and then we're just going to go ahead and punch that into our calculator. So our acceleration will be 2.26 times 10 to the exponent of 12 meters per second square, right? So this is basically just how you were supposed to calculate that question. So first, it's this formula here. So I do understand that a lot of you do not get to see or use this formula a lot of the times. So it's just one of those formulas that you really need to be mindful of. It is not very common for you to have a question that requires you to use that formula. But then there we had that dilemma in your prelim exam. So you really need to put it in the back of your mind that such a formula exists and know how to apply it and when to apply it. Right, so now we have 7.4. It says if an electron was placed at point P, so if now an electron instead of a proton, so if an electron was placed at point P instead of a proton, how will the acceleration of the electron compare to that of the proton? Now we know our electrons are much bound to have a smaller mass, and then according to F net is equals to ma, we know that acceleration is inversely proportional to mass. So we'll say this one would have a larger acceleration. So there will be a larger acceleration due to the electron having a smaller mass. And then that is based on the relationship. Acceleration is inversely proportional to the mass of the object according to Newton's second law. And then obviously, since now it's an electron and not a proton, we expect that the electron would accelerate in the opposite direction. Would accelerate in the opposite direction of motion. Right. So that's it. So that's commenting on the acceleration of the object. Remember, acceleration is both has both magnitude and direction because it is a vector. So we need to mention how it will be moving and also the direction in which it will be moving. So large acceleration due to the electron having a smaller mass, and then the electron would accelerate in the opposite direction. And this would give us 2 marks. So all in all, this question was worth 13 marks. And then that's all you needed to figure out there. So only difficult question I would say was 7.3. But then also it required you to know a particular formula and how to apply that particular formula. So much more practice, and then with more practice, remember you get to see different ways in which questions can come. So it puts you at ease and actually works in having to minimize that exam anxiety when exam time knocks in, right? So with all that being said, guys, please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.